everybody. I hope you guys are having a wonderful day today. So in this video, we're going to talk about what a graph is, specifically the graphs that we'll be using in our graph theory unit. So go ahead and take 3 deep breaths, and let's make this math easy. All right, so the definition of a graph is that it's a set of vertices and a set of edges that attach pairs of the vertices together. So in a graph diagram, the vertices are drawn as dots, and they're usually used to represent individual objects. So they might represent cities or people, or they could be used to represent land masses. Basically, any type of individual objects can be represented with vertices. And then edges are drawn as lines that attach pairs of vertices together, and they're used to represent relationships between the objects. So for example, if your vertices were representing cities, maybe the edges would represent whether or not there's a road between the cities. Or if your vertices represented people, maybe the edges could represent friendships between people. So if we were to use that example, the person that the red vertex represents would be friends with the person that the yellow vertex represents. But he wouldn't be friends with whoever the blue vertex represents because there's not an edge that attaches the red vertex to the blue vertex. And one of the things that's kind of interesting about graphs is in the diagram, it actually doesn't matter where you put the vertices. So these 3 graphs that I have drawn here are actually all the same graph. They're just drawn with the vertices in different locations. But the most important thing about a graph is which vertices are attached to each other. And so the reason that these 3 graphs are the same graph fundamentally is because if we look at it, the yellow and red vertices are attached to each other in all of the graphs. So that relationship is consistent between all of them. Same thing with the green and yellow. Those 2 vertices are attached. The green and blue are attached. And the blue and purple are attached. And the yellow and purple are also attached. And so because we have the same vertices and the same edges, that means that all 3 of these graphs are essentially the same graph. So it doesn't matter where the vertices are, and you're welcome to redraw graphs by rearranging where the vertices are, as long as you make sure that the edges that attach the vertices together are the same edges. So one of the vocabulary words that we use in graph theory quite a bit is the word adjacent. So 2 vertices are adjacent if there's an edge that attaches them to each other. So for example, in this graph, the green vertex is adjacent to the yellow and the purple vertices. The blue one is adjacent to the yellow, purple, and red vertices because there's an edge that attaches the blue vertex to the yellow, purple, and red vertices. And the black vertex is not adjacent to any vertices because there are no edges that attach the black vertex to one of the other vertices. So that's one of the vocabulary words you'll need to know. And then we also have loops. So a loop is a special type of edge that attaches a vertex to itself. So in this graph, we have 3 loops. We have the loop that attaches the red vertex to itself, right here. And then we have the loop that attaches the purple vertex to itself, as well as the loop that attaches the green vertex to itself. So loops are special types of edges. And we can describe vertices with a number called the degree of a vertex. So the degree of a vertex is defined as the number of vertices that are adjacent to it. So if we look at this graph, the degree of the green vertex would be 2 because there are 2 edges that leave the green vertex and attach the green vertex to the yellow vertex and the purple vertex. The degree of the blue vertex would be 3 because there are 3 edges that leave the blue vertex and attach it to the yellow, purple, and red vertices. The degree of the red one would be 2. The degree of the purple one would be 3. And the degree of the yellow one would be 4 because it's attached to 4 different vertices. And then the degree of the black one would be 0 because there are no edges that attach the black vertex to any of the other vertices. So the degree of a vertex is a number that describes how many vertices are adjacent to that vertex. The next vocabulary word we need to know is subgraphs. So a subgraph is a graph that includes some of the vertices and edges of the original graph. So say, for example, we had this original graph. The graph that I've drawn over here is a subgraph of this original graph because it has some of the same vertices and edges of the original graph. So if we look at this subgraph, we can see that it includes the red vertex, the green, blue, and purple vertices, as well as these 2 edges. And the reason it's called a subgraph is because it's part of the original graph. It doesn't include everything from the original graph because we're missing these edges and this vertex, but it does include some of the vertices and edges of the original graph. So there's 3 special types of subgraphs we're going to be studying more in later videos, and those are called paths, circuits, and spanning trees. So we'll learn more about those in later videos, but this is just kind of a heads up of what a subgraph is, and then we'll look at those special types a little bit later. The last vocabulary word we need to know is the weight of an edge. So the weight of an edge is a number that represents something about the relationship between the 2 vertices that the edge attaches to each other. So for example, let's say that the vertices in this graph were representing different cities. Well, if they represented different cities, we might have the edges representing maybe if those 2 cities have a bus route between them. And we could have the weight of the edge represent the cost of the ticket to ride the bus from one city to another. So a weight is basically a number that describes something about the relationship between the 2 vertices. Because remember, edges describe relationships between the vertices, and a weight of an edge is basically a number that gives you kind of like more specifics about what that relationship is. So it could be like a money number, like in this case, but you could also have it maybe be measured in miles. So if it was not bus routes between cities, but it was like roads between cities, you could have how many miles long that road is. Or if you had the different vertices representing maybe like different land masses, you could have the edges representing bridges between those different land masses, and maybe the weight of the edge could be the cost of building that bridge. So there's a lot of different things that you could use the weight of an edge to represent, but in general, it's a number that represents something about the relationship between the vertices. And when you have weighted edges, sometimes the graphs will be represented as tables instead of as diagrams. So remember, graphs are sets of vertices and edges that describe relationships between the vertices. So a lot of the time we'll use diagrams to draw these relationships, but sometimes you may also represent them in a table. So for example, this graph that we used on the last slide could be represented with this table here. Because if we look at it, the columns and the rows of the table represent our different vertices, and then the different spots on the table represent whether or not there's an edge between it and what the weight of the edge is. So like if we look at this number, for example, that number is telling us that the red and yellow vertices are attached to each other, and that edge that attaches them has a weight of $36. And you'll notice that in the table there's always doubles, because if the red is attached to the yellow, you could also say that the yellow is attached to the red. So your table will always have duplicate numbers that represent each edge. And you can see like the blank spaces are basically communicating where there are no edges. So there is no edge between the red and green vertices, and so that's why there's a blank space here. So most of the time we represent graphs with diagrams, but we will also represent graphs as tables as well. So that's it for this video, and I hope you guys have a good day.